Welcome back to my channel for data, machine learning, and tech career. In today's video, we're going to answer a very common business question such as like, why are people churning from our platform, and what can we do to prevent it? So this is a very common question being asked across all industries, all companies, and we can use machine learning model to answer this question. So whenever we're trying to understand why people are churning, we usually want to include like these three types of metrics. So first one is engagement metric. So understanding how long do they spend on your product and how often do they use your product are called engagement metrics. And user stats are what we call like user tenure, like how long have they been your customer, and like number of products they use from your company. That will also be very informative. For example, if Facebook has Messenger, has Facebook app, has Instagram. So if they use multiple, then they're less likely going to churn from your whole company ecosystem. And then for user experience, usually I'll include more like negative, metrics such as like, oh, how many times did the mobile app reboot, or how many times did the mobile app like stop working, and those are what I call user experience metrics that will kind of cause a reason why people wouldn't want to use it anymore. And it can be various of reasons of why it has to reload and reboot, but I think understanding what if those are the key drivers to people churning, then we can look into like what else can we fix for those metrics. So usually after you have came up with, let's say 80 to 100 metrics that you think has impact on churn, then usually you will want how to use like a binary classification machine learning model. And logistic regression is a very more straightforward and simplest machine learning model to answer this question. And it's usually a feature importance model gives you a pretty nice like positive and negative impact on each feature, so you can kind of see which one has the highest impact, and then versus the worst impact, and also the order of which one is more important, and tells you positive or negative signs. And this is very helpful in terms of understanding what are the key drivers that's driving churn. But like in most cases, when you use like other machine learning models like deep learning or XGBoost or random forest, they're all more like a like a black box in terms of like a feature importance, because all it really does is to kind of give you the feature importance based on like most important to least important, but doesn't really tell you the positive and negative impact like logistic regression. But usually other like not always, but XGBoost or random forest usually have a higher accuracy in terms of your machine learning model, so you do have that trade-off. But then there is a new package called SHAP. It's like a game theory model that can built on top of whatever model you're building, like deep learning or XGBoost, and then give you a more explainable output in terms of feature importance model, and to be at the same time to be more accurate. And the other thing is also that the feature importance model can have various versions by importance type. So like for example, in this example, that XGBoost has this importance model that's outputting like age is the most important, and then when you change it to importance type to be covered, then the most important feature became capital gain. But look like how like it's completely shifted the feature importance from the highest to lowest like a lot, based on depending on which importance type you're using. And so that's what is also useful for SHAP, because it's using the game theory model of like kind of like reshuffling all your features in your tree model, so then like it's actually more consistent across the board, instead of like this is causing inconsistency in your feature importance model. And so that is why SHAP will be very useful in this situation. So SHAP model is an add-on model that's on top of your base model. So usually you have a base model like logistic regression or tree, decision tree, or random forest. And so the SHAP model actually has all these different explainers that can be applied depending on what your base model is. So first one is tree explainer, So any random forest XGBoost can be classified into this explainer. And then you have linear explainer, which can be used for linear regression, logistic regression. And then you have gradient explainers, so like light GBM, other gradient related machine learning models. And then you have deep explainer, which is for deep learning. And kernel explainer is actually for a more generic application. So if you don't know which model is your base model, then you can probably use kernel explainer, which is more generic. So before I jumping into looking at what are these like useful charts and models that SHAP can produce, please make sure you subscribe to learn more about data. And if you do want me to like walk through like how do you use XGBoost model maybe with the sample data sets, then please make sure you comment, and then I'll make sure I include it in order to use your SHAP value. You have to get the model first using whatever like XGBoost or gradient models that you want to use. And then but then you have to have a model output first with the whatever data you're training on. And then after you do that, then you can have the explainer equals SHAP.tree explainer parentheses model. So this model is the model that you just already created from your XGBoost model. And then we're using a tree explainer because XGBoost is a tree model. And so that's how we're going to generate our explainer. And then we're going to generate SHAP values using the explainer.SHAP values parentheses x. So x is our data set that contains all the metrics or all the features that you included to your train model. So there are two types of summary plot, and this is the simpler kind that is a bar graph and pretty much looks exactly the same as how you would generate a feature importance plot in the XGBoost model. And then so you just simply have the feature and then what is the bar of like how important it is, and it goes from highest to lowest. But then I'm gonna go explain the other more complex summary plot. I'll give you actually a lot more information than this, but this is a good start to understand which feature is more important than the other one without knowing which direction it's gonna impact. So this is the second summary plot that's even more useful than just telling you which feature is more important, and you can generate this plot by SHAP.summary plot parentheses SHAP values comma x, which is your data set, and your SHAP value is generated from your explainer SHAP value from the syntax that we went over earlier. And then with this output, it shows you every single feature from the most important to the least important, and then also showing you if a feature value is high, which is in red, then does it have a positive impact on the model output or does it have a negative impact. So the general idea is that if the red is on the right hand side of the box, then it's positive, and if the red is on the left hand side, then it's negative. For example, if you look at the first feature here, so blue on the left is fine. As long as the red is on the right, then it's positive, because it's not just it's not just one side bar graph. It's actually a spectrum, and of course every single feature is a little bit of a spectrum. It's not really like, oh yeah, if you have this feature, that you're definitely going to churn. It's not 1 or 0 binary outcome. So it is a spectrum, but then the general idea is looking at how which feature has the most important to the least important, where it's like almost neutral or almost no one knows what the impact is at this point. Then these are what we consider as like not as important feature that will cause churn. And it's very clear that the first feature has a very positive impact on a churn. So then that means this is the most important churn driver. So the last SHAP package plot I really like using is the SHAP.dependence plot, and you can apply by using SHAP.dependence underscore plot parentheses feature name comma SHAP values and comma x, which is your data sets that you originally trained the model with. And then you can use, like, after you run this, it'll generate this plot which will tell you what a SHAP value is with that specific feature. So in this example, I'm just using a binary, like if they have mobile or no mobile. So for example, like maybe let's say number 2 means there is mobile, number 1 means there's no mobile. And then so based on this, you can kind of see, okay, has mobile has a slightly higher chance of churning, right? Because it's a little taller. So the more positive means the more likely they're going to churn. The mobile or not category is the most relevant feature to error rate. And for example, if the error rate is for mobile only, it's going to show that if you have more mobile error problems, and it's more likely you're going to churn. And that's the reason why it will show red on the top for in this case. But I'm just giving an example. This is not exactly how the data set was supposed to be. But if you want to learn more about the SHAP package, please leave a comment below, and I'll always happy to go over more details.